Let's do class example number 1 on page 118. So in this example, again, we're going to follow our rules. So if you recall, the steps are that we divide numerical coefficients with numerical coefficients and radicands with radicands. And we have to make sure that the index are the same. So let's try the first example here. So there are no numerical coefficients for me to worry about in part A, but I do have to make sure that the index are same. So in this case, both of them are square roots, so we're okay. So, and this is going to be root 30 divided by root 6. So again, remember, you don't have to write it this way, but it is the same thing as this. So sometimes that helps us to kind of see that. And then if we were to reduce it, then they both get reduced and it becomes 5 over 1. Okay, so you could do that right over here. This is 5 and this is 1. So that gives you root 5 over root 1. And what we know is that root 1 just means 1, and that means our final answer is root 5. We always try to check in the end if you can simplify this radicand any further. In this case, we can't, so that's our final answer. Okay. Now, let's see if we have something like what they have in part C. So the numbers are a little bit more complex, but we're going to use the same rules here. So we have 15 over 10. So that's the numerical part. So I like to see them separately here. So 15 and 10, they don't divide out completely, but what they do is they reduce each other, right? So I can reduce these. They both get divided by 5, giving me 3 over 2. So I can write that answer as 3 over 2. And the same thing happens with my radicand. So I'm going to divide my radicand with a radicand here. So that's going to be 48 divided by 6. So in this case, that will become 1, and this will become 8. Again, I don't need to write root of 1. Remember, I said it just is going to become 1 anyways. So I can leave that out. Now, we're done with the division part here, but remember the last part of it is always trying to make sure that we have reduced our radicands completely. And root 8 is not completely reduced. So if you remember, root 8 can be further reduced to root 4, root 2, which becomes 2 root 2. So that's what I'm going to go in and put in place of root 8 here. So root 3 is already there, times by 2 root 2, everything divided by 2. Okay. So here you can either reduce the 2 and 2 each other, they get reduced, or you can think of it as 6 root 2 divided by 2, which then becomes 3 root 2. Now this is the final answer. Okay, so divide your numerical with the numerical, radicand with the radicand, and then we check to see if we can reduce it further. Okay. The idea is the same with even with our variables. So what I would like you guys to do is I would like you to pause this video at this point, and I want you to try part B and D on your own. The answers for these two questions are given on this Moodle page, as you've already probably seen. If you get the same answers, then you're good to go. You can move on to the next example. And if not, then I want you to come back and restart this video again at this point, and you can watch me finish this question. Okay, so pause your video, take some time to finish these questions. All right, so I'm going to think you paused at this point and tried these questions, and maybe there was up somewhere that you need some to see where you might have made a mistake. So let's take a look at it. So in this case, we check that these both have the same index. So that means I can divide the coefficients with coefficients. So that's a 4. And then here they will divide out, this becomes a 7. Because the denominator is just 1, and whether we're taking a square root of 1, cube root of 4th root of 1, 1 is just 1. So I'm not going to write it over 1. So this will just become 4 cube root 7, and that's our answer because we can't reduce this any further. On to D. So in this part, what will happen is the 4 will reduce the 12 this time, so this will become 1 over 3. So again, if you want to, like the 1, to keep it there as a placeholder for numerator, you could. And the A will divide the A out. Again, In that case, this will end up becoming root of 1. And in the numerator, we'll end up with root b. So you end up with 1 root b over 3. Or you can write 1/3 root b. That is okay too. Or you could write root b over 3. Any of these versions for this answer is correct. Right, so remember, there are also videos in your Moodle lesson. If you want to see another version of Being It Explained, you're more than welcome to watch those videos or look for the answers in the solution manual given in the resource section.